For example 1c, we have to identify the GCF for this trinomial. Notice how all the variables, or excuse me, all the terms have the variable p, so our GCF is just the variable p. There is no numerical GCF to factor out other than 1, and there is a variable that can be factored out, p. So once that p gets factored out, then we have 4p squared. P times 4p squared gives us 4p cubed. Then p times a plus 20p, and then the last one is p times 25, so positive plus 25. So now we have to see if this trinomial will factor further. You can use the AC method to factor this trinomial. However, the first term is a perfect square. 4p squared is a perfect square. 25 is a perfect square. And the middle term is twice the square root of the first term times the square root of the last term. So we'll take a look at that, because this will factor as a perfect square trinomial. And so we're going to prove that by showing the square root of 4p squared is equal to 2p. 2p times 2p gives you 4p squared. The square root of 25 gives you 5. And now we need to check, does this middle term, this is the most important part, 20p, does that equal twice the value of our 2p times 5? And 2 times 2p is 4p, 4p times 5 is 20p. So this in fact does meet the requirements of a perfect square trinomial. Because it's a positive 20p, we're going to test it with plus 2. If this was a minus 20p, then we would test this with a negative 2 as part of the rules for factoring perfect square trinomials. And so now that we know it's a perfect square trinomial, it is going to follow the pattern, and this plus sign is going to help me here. It's going to follow the pattern of a plus b in parentheses squared, where a is the 2p and b is the 5. So I'm just going to write that there, 2p plus 5 in parentheses squared. But again, do not forget we had that GCF at the very beginning factored out of p, so that's going to go in front of this perfect square trinomial. And now I have my final answer for example 1c.